ஓகே லைவ் ஆயிடுச்சு. ஸோ இன்ட்ரோடியூஸ் பண்ணிருங்க மேடம் நீங்க அப்படியே.
எஸ் சார். சார் வணக்கம். நம்ம வந்து ஆக்சுவலா 2 கிளாஸஸ்ல வந்து 2 செஷன்ல வந்து ஸ்டீம் சிஸ்டம் பார்த்துட்டு இருக்கோம். ஸோ ஃபர்ஸ்ட் கிளாஸ்ல வந்து ஸ்டீம் சிஸ்டம்ல ஃபர்ஸ்ட் கிளாஸ் நம்ம பார்த்தது வந்து பேசிக்ஸ் ஆஃப் ஸ்டீம், ப்ராப்பர்ட்டிஸ் ஆஃப் ஸ்டீம், லிக்விட் என்தால்பினா என்ன, என்தால்பி ஆஃப் எவாபரேஷன், phase diagram, அப்புறம் how steam is distributed, distribute ஆகும்போது என்னென்ன ஃபேக்டர்ஸ் வந்து அஃபெக்ட் ஆகுது, அப்புறம் பைப் சைசிங் என்னென்ன. ஸோ இதை பேஸ் பண்ணி நம்ம வந்து ப்ராப்ளம் ஷேர் பண்ணி ஒர்க் பண்ணிருக்கோம். ப்ரெஷர் ட்ராப் கால்குலேஷன் அதை பேஸ் பண்ணி பைப் சைஸ் டயாமீட்டர் கண்டுபிடிக்கிறதுக்கும் ப்ராப்ளம் ஒர்க் பண்ணிருக்கோம். ஸோ அது ஃபர்தரா அடுத்த கிளாஸ்ல அதோடைய கண்டினியூஷன் வந்து ஸ்டீம் அண்ட் அதோடைய டிஸ்ட்ரிபியூஷன், எஃபிஷியன்ட் ஸ்டீம் யூட்டிலைசேஷன், எப்படி வந்து அந்த எஃபிஷியன்சி வந்து டிராப் ஆகி ஓவரால் எஃபிஷியன்சி நம்ம எப்படி அரைவ் பண்றோம், அப்புறம் ஸ்டீம் யூட்டிலைசேஷனை பேஸ் பண்ணி ப்ராப்ளம்ஸும் ஒர்க் அவுட் பண்ணிருக்கோம். இப்ப இன்னைக்கு உள்ள கிளாஸ்க்கு இதோடைய கண்டினியூஷனா இன்னைக்கு 3.5ல இருந்து அப்படியே கண்டினியூ பண்ண போறோம். ஸோ வில் ஸ்டார்ட் வித் ட்ரையர்ஸ்.
மேடம்
ஸ்லைட் ஷேரிங் தான் பார்த்துட்டு இருக்கேன். ஒரே ஒரு 2 minutes சார்.
ஓகேங்க மேடம், ஓகேங்க மேடம், டேக் யுவர் டைம். தேங்க் யூ.
Sir, good evening, sir.
குட் ஈவினிங் சார். வணக்கம் சார். வணக்கம் சார். மேடம் வந்து கிளாஸ் எடுக்கிறதுக்கு ஸ்டார்ட் பண்ணிட்டாங்க சார். உங்களுக்காக வெயிட் பண்ணி பார்த்துட்டு. ஷாக் ஆயிட்டீங்களா சார்? இல்லைங்க சார், சும்மா சொன்னேன். 9:30க்கெல்லாம் ஸ்டார்ட் பண்ணிடலாம் அப்படின்னு சொல்லி ஸ்டார்ட் பண்றதுக்கு முயற்சி எடுத்துட்டு இருக்கோம் சார். ஸோ ஸ்டார்ட் பண்ணிட்டாங்க மேடம். இந்த இது ஷேர் பண்றாங்க, ஸ்லைடு ஷேர் பண்றதுக்கு அவங்க கம்ப்யூட்டர்லயும் மொபைல்ல இருந்தும் ட்ரை பண்ணிட்டு இருக்காங்க.
ஓகே ஓகே ஓகே
ஓகேங்க சார். மேடம் ஏதாவது சிக்கல் இருக்குங்களா மேடம் உங்களுக்கு? என்னங்க மேடம்? இல்ல ஷேர் பண்றதுல என்ன மேடம் சிக்கல்?
நீ பண்ணால இவரு தான் சொன்னாரு இப்ப நீ பண்ணி அவருக்கு
சார் இப்ப ஷேர் ஆகுதுங்களா?
நல்லா ஷேர் ஆகுதுங்க மேடம். ஸ்பீக்கரும் சேர்த்து. ஸோ ஒன்னு மியூட் பண்ணிடுங்க மேடம். இந்த கிளாஸ் நல்லா இருக்கே.
ஆமாங்க அப்புறம் ஏங்க
Yeah, class continue பண்ணலாம் சார். So இந்த கிளாஸ்ல we are going to deal with drying sir. So drying
அது
it's a
PPT
process.
மோடு மாத்திடுறீங்களா மேடம்? ஷோ மோடு.
Show mode.
ஆமா மேடம். ஓகேங்க மேடம், நீங்க ப்ரொசீட் பண்ணுங்க.
So drying is a process by which the liquid is removed from a material. So normally this is done by applying the heat, and mainly the steam is used as the working fluid here. And sometimes we use a carrier gas. It may be a flue gas. So the basic drying energy requirement will be the latent heat. So already before class we have seen what is latent heat and what is sensible heat. So here the majority energy consumption will be the latent heat, because there will be a phase change in from the vapor to in the vapor phase. So another one parameter we have to consider here is about the amount of water being evaporated, because the latent heat will be equivalent to mass of the moisture to be evaporated into the latent heat. So M is the main factor where we need to calculate in the drying process. So this shows us a hot dry air using steam. So this is basically a heat exchanger where you have send in the steam for exchange of heat, and it leaves outside as a condensate, and the air is entering as at a time lower temperature, gets the heat from the steam, turns out to be hot air. So here, when we need to find out the total energy required, these are the heat what we have to take into consideration. One will be the heat leaving the dryer in the exhaust flow. So that includes the latent heat of the water evaporated, and also the sensible heat of the hot gas. Why we are saying here the sensible heat is, it is the MCP into del T. So that may also be significant sometimes. So it also needs to be calculated. And the second one is heat lost from the equipment and ducting. So even though we provide good insulation, there will be always some heat loss. So that also has to be taken into consideration. And third is what is the heat leaving the dryer as the hot product? What is the heat gained by the product? And at the last is the what is the power spent for taking the force? So in order to take the heat energy, what is the amount spent auxiliary consumption? So that also has to be taken into account. So these are the major common factors resulting in the excessive energy usage. So certain time we need to check in all these factors while we are designing a drying system. Sometimes the drying load may exceed beyond our design. Sometimes the exchange of heat, the airflow may be excess. And the third case may arise, the hot exhaust flow that may be unnecessarily entry will be there. And leakages will be there, that we call it to be the hot air leakages. And due to poor insulation, there may be some loss. And in the worst case, sometimes if the proper design is not there, the fan used will be more. So excessive fan power will be directly proportional to the efficiency loss, because the heat will not be taken by the other fluid due to the excessive power. So all these are the steam system inefficiencies. So these have to be considered at the design itself. So we'll work out one problem in heat energy in air drying. Some type of problems are asked in the university questions in our energy audit also. So if you have your notebook, kindly take it. You can also have your calculators, please. First, we'll read out the problem. A food containing 80% moisture, 80% to be dried at 100 degrees centigrade down to a moisture content of 10%. If the initial temperature of the food is 21 degrees centigrade, calculate the quantity of heat energy received per unit weight of the original material for drying under atmospheric pressure. The latent heat of evaporation of water at 100 degrees centigrade and at atmospheric pressure is 2257 kilojoules per kilogram. The specific heat capacity of the food is 3.8 kilojoules per kilogram degree Celsius, and of water is 4.186 kilojoules per kilogram degree Celsius. Find also the energy requirement per kilogram water removed. So this is the problem given. First of all, when we are given a problem, we need to read the problem and write the given data. So in the first statement, it is given a food is containing 80% to be dried, which is at a temperature of 100 degrees centigrade, down to a moisture content of 10%. So that means we have to interrupt the given data in terms of numbers. So initial moisture is 80%, which again means 800 gram moisture is there, which is associated with 200 grams of dry matter. And the final moisture to be dried. So after drying, it becomes 10%. So 10%, 100 gram moisture is associated, whereas 900 grams have been dried. It has been converted into, the moisture has been gone. So we need to find out how much moisture is there. That is our problem here. So this is our solution. So when a problem is given, we need to write the given data. Then we need to find out what are the steps involved in finding out our end product. So our end is step 4. The question asked is the energy per kg of water removed. So in order to find step 4, we need to find out step 3, which is the total heat energy required for 1 kilogram of the original material. Because in the problem, it is given, calculate the quantity of heat energy required per unit weight of the original material. So initially when it is entering at atmospheric pressure, so that is the case here. So we need to find out the heat energy required for 1 kg of original material. So this will be the step 3. So in order to find out the step 3, we need to find out step 1 and 2. So we'll do one by one. So step 1 will be to find out the moisture associated with 200 grams of dry matter. So why it is 200 here? It is because of the given data. So step 1 is moisture associated with 200 grams of dry matter. So which is equivalent to 100 by 900 into 200. The reason is here. So this is 100 gram, 100 by 900. For 200 grams, we are going to find out. So which is by calculation, it is equivalent to 22.2 grams of moisture. So this much amount of moisture is associated with 200 gram of dry matter. So this is the first step. And we move to the second step. This is a very important step because we need to find out this M. When we multiply this M with the latent heat, we'll get the latent heat of evaporation. So 1 kg of original matter has to lose 22.2 gram from the original. So it is 800 minus 22.2 gram of moisture, which is equivalent to 778 gram of moisture. So the mass is equivalent to, in terms of kilogram, if you want to say, it is 0.778 kilogram of moisture. Then step 3. To find out the heat energy required for 1 kg of original material. So which will be equivalent to the summation of 2 heat. One will be the sensible heat, that is the heat energy to raise the temperature from 200. Initially it is at 21. I think the temperature, it is given in the third line. If the initial temperature of the food is 21 degrees centigrade. So we need to convert till 100 degrees centigrade is reached. So that means the sensible heat added will be again by the same basic formula of mCp del T, where Cp is the specific heat of the food. It is given in the problem itself. It is 3.8 kilojoules per kilogram degree Celsius. And T1 is the highest temperature, it is 100. And T2 is the 21 degrees centigrade. So if we calculate for 1 kg, we are calculating. So mass is taken to be 1 kg. So QA will be equivalent to, if you multiply, it is 300.2 kilojoules. So this is the sensible heat utilized. The other heat will be the latent heat required to remove the water. So this is given by the equation of mass into latent heat of vaporization. So latent heat of vaporization, it is given in the problem as given data, 2257 kilojoules per kilogram. Whereas mass is the moisture where we have found out in the step 3, step 2. So step 2 at the end we have found out to be 0.778 kg of moisture. So this we have to use it here and calculate the latent heat to remove water. So if you calculate, it comes to around 1755.9 kilojoules. So the total heat energy will be the addition of 2. And the final step will be to find out for per kg. That means here 2057 kilojoules have been arrived. So they are required to remove 0.77 kilogram of water, which means what is the energy per kg? That is our final question asked in the problem. So we divide it by mass. So it is 2643 kilojoules per kilogram of energy requirement is the final answer. So this is one lengthier problem, but similar problems have been asked in the questions. So first, if a problem is given like this, we need to read it, write the given data, and arrive the various steps. Then substitute one by one, and we will get the final answer. So it will be the addition of sensible and the latent heat only, but the terms we have to put in correctly. Shall we go to the other topic, sir? Yeah. So the other one is the proper selection, operation, and maintenance of steam traps. So in the earlier class, in the last class, we had seen what is steam trap and what is the purpose of it. So in order to have the efficiency to hold good, we have some traps to let off the condensate, any air present, or any non-condensable gases present in the steam. Otherwise, what will happen? The condensate will be formed inside the pipe, which will reduce the temperature of the steam. Ultimately, the efficiency will go on decreasing. And based on that, also we have done one problem. I hope you can recall it. In the previous class, we have worked out how much temperature it has been reduced while if a amount of air is trapped inside. So the purpose of the steam trap is to obtain the fast heating of the product and equipment by keeping the steam lines and equipment free from condensate, air, and non-condensable gases. And what is a steam tap? It is a simple valve device, so which will discharge the condensate and the air without discharging the steam. So that is the highlight of the steam trap. It is a trap only, but it will discharge only the condensate and the air. If steam is lost, then of course our total system will collapse. So what are the main functions of the steam traps? So it does 3 important functions. It discharges condensate as soon as it is formed. If it is staying there inside the steam trap, then again pressure drop will come there. And thereby, as soon as the pressure drop arrives, it opens up and it delivers it outside. And not to sir, is there any net problem? Please stay in, sir. There is some net problem. I'll again reconnect. And the second function was not to allow the steam to escape. And the third one is it should be able to discharge the air and other non-condensable gases then and there. So these three are the main important functions of the steam trap. So is it audible or?
Madam, audio only received, madam.
Yes, sir. I'm reconnecting it. There is some network problem here. So we'll see the three types of steam traps. I'm also trying the slide sharing, sir. It will come. So there are three basic types of steam traps available based on the ISO 6704 and 1982. We have whatever may be the steam traps we use. It comes in categories. One is the thermostatic, another one is the mechanical, another one is the thermodynamic. So thermodynamic, first we'll see what is thermostatic. So thermostatic steam trap is operated by the changes in the fluid temperature. So fluid temperature changes. Slide. Slide is there, sir. Oh, sorry. So temperature of the steam is determined by the pressure. So how this is possible? In the thermostatic steam trap, we have a steam space where the steam is giving up the enthalpy of evaporation. And after some time, it produces some condensate, say at a temperature, lower temperature. So when this lower temperature is sensed, the thermostatic trap will start to work. And the condensate is given out from the thermostatic steam trap to the atmosphere. So normally we use a float trap with air cock type. So your float will be inside the cavity where you have the high pressure steam. It is entering into the cavity. Suppose a condensate is formed there, condensable gases, or here condensate is formed. The float starts to lift, which lifts the valve. So a pressure drive is created and thereby the condensate is thrown outside. And again the lock is created. So this goes on whenever the accumulation of condensate happens, it automatically works, just like a lever arrangement. Another one type is the float trap air cock.
Ma'am, 1 minute, ma'am. Ma'am, screen share பண்ணிருக்கீங்களா மேடம்?
Screen sharing is பண்ணிருக்கேன் சார், பட் அது நெட்வொர்க்னால கட் ஆகுது.
சரி மேடம், சரி மேடம், ஒன்றும் பிரச்சனை இல்லை. நீங்க அப்படியே சொல்லுங்க மேடம், நாங்கள் ஷேர் பண்ணிக்கிறோம், கேட்டுக்கிறோம்.
Yes sir.
தேங்க்யூ மேம், தேங்க்யூ.
So float trap with the thermostatic air vent. So here this system utilizes a balanced pressure capsule element. So the same principle of the earlier one, but here you have a air vent. So the air vent is responsible for the release of the air and thereby the condensable gases does not get accumulated during normal running. So this is also a thermostatic steam trap. The other one is about the mechanical steam trap. So mechanical steam trap means it is operated by the changes in the fluid density. See, why comes there is a change in the fluid density here is the mass is going to be the same, but there will be a change in volume. So here you have a two-phase mixture. So there will be a change in volume. So wherever condensate is there, you have a change in density. So the mechanical steam trap operates by sensing this difference between the steam and the condensate. So again, this utilizes a ball float trap and inverted bucket traps. So I'm not in a position to show you the diagram, but anyway, it is very self-explanatory. You have an inverted bucket where it is attached to a lever. So in this inverted bucket, when the steam gets accumulated, it lifts the entire part and the condensate is blown outside. So this is the mechanical inverted bucket type. So third one is the thermodynamic steam trap. So thermodynamic steam trap, this gets operated by the changes in the fluid dynamic system. So in the last class, we had seen the formation of flash steam. So flash steam is something which comes out instantly. So due to this instant reaction, there will be some change in the thermodynamic system and it pushes the upper part of the disc where you call it to be a moving part. So that will act as a stop. So that will make the excess to be pushed outside. So this is what is happening in the thermodynamic system. Go to page number thermodynamic. So we have seen three types of steam traps. One is the thermostatic steam. Another one is the thermodynamic steam trap and thermostatic and mechanical. The last one is the mechanical. Mechanical is you have an inverted bucket type. So this is what is about the steam trap. And the other topic is about the installation of these steam traps. How to install these steam traps? What are the main criteria which we need to follow it during the installation? So in order to have a trouble-free installation, careful considerations need to be done to the following. So first one will be the drain point. So drain point the condensate should flow easily. So the condensate should flow easily into the trap. Otherwise, there will be some pressure drop. So thereby, we introduce a proper pocket at the lowest point of the pipeline. So that is needed. So second one is the pipe sizing. So the pipe sizing, the various pipes, they are directly proportional to the pressure drop. So the pipes leading to and from the steam traps, they should be of proper size, particularly in the thermodynamic steam trap, because in the thermodynamic steam trap, it is directly proportional to the density. So mass into the volume flow. So it will be equal to pi by 4 d square. So we need to take careful consideration of the pipe sizing. And third one is the air binding. So air binding is adequate provision should be given for removing the air either by the steam trap itself, because in the mechanical steam trap, the air vent is at the top. So it is in line with the pipe. In some cases, a separate air vent is provided. So whatever may be there, the air binding provision should be given. The other one is the steam locking. So steam locking, the trap is locked shut by the steam. If you take the mechanical steam trap, it is an inverted bucket form. The steam comes and accumulates inside the trap, and because of it, it is shut instead of air. The example is the float trap, which acts as a steam lock release arrangement. So you can just go back to the diagram also, because the network is very wavy. Like it takes some time to go back to the diagram. So I'll just explain. So steam locking is very important here in the installation of the steam traps. And the other one is the group tapping versus individual tapping. So here, if we have a single system, we have a single pipeline, main pipeline, and from that you have a steam trap. It may be either a thermodynamic steam trap, or it may be a thermostatic or a mechanical one. But it will be an individual unit. You have only one system. So only one pressure loss will be there. Only pressure drive will be there. But normally in other firms where we have a number of units in process, in order to save energy or money, even you say, group trapping is followed, but actually it doesn't do that. So group trapping is connecting several units to a common steam trap. That you call it to be the group tapping. But what actually happens here is the steam consumption will not be the same in all the units. So it will vary from region to region, from process to process. So the mass flow rate will vary, which ultimately will change the pressure drop. So the pressure at the drain unit, it will be heavily loaded. So the efficiency will not be, it will go down. So normally group trapping is not advisable compared with the individual trapping. It may take some effort to go for individual trapping, but group trapping normally we avoid it. The other one is the dirt. So the common enemy of steam traps, we know, it is the dirt. The dirt accumulation, which is taken along with the useful heat energy. So it is the cause for many failures. So normally it is advisable to use strainers which is kept before the steam trap. That is before the pocket, right? So which prevents the dirt passing into the system. And the main usage of the strainer here, if keep strainer, it doesn't mean the dirt doesn't go inside, but periodical cleaning and maintenance of the strainer and replacement of the strainer is also needed, because this is going to be exposed at a higher temperature. And the other one is the water hammer. So this is also asked in some questions. Actually, this we might have heard in the hydropower plant. What is water hammer, surge tank? That is when the water hammer, when we apply it in the steam traps, when the condensate gets collected in the pipe work. So it is going on getting collected, it will be moving. So already there is some fast moving steam inside. So when it is picked up by this pressure drive, suppose if there are some obstructions such as bends or any valves on the way, so what will happen? It will go and they have some impact on it. So which will cause severe damage to the materials. So that we call it to be the water hammer. So that has to be taken care while the installation of steam trap at the design time itself. Otherwise, we need to change the entire layout, which will have a loss of money at the installation cost. Everything, the rework has to be done. So water hammer has to be taken care at the initial installation of the steam traps itself. And the other one is the lifting the condensate. So during the installation of the steam traps, lifting the condensate, it means, see, actually the condensate, when it forms inside the steam trap, it is lifted up due to the pressure difference, or it may be due to the density difference, right? So a check valve may be fitted where the condensate is going to be accumulated. So why this check valve is fitted is, it prevents the backward flow. Again, ultimately it increases the efficiency, that's it, right? So these are the main considerations where we need to take in during the installation of these steam traps. So various points we had seen. And now we will see about the maintenance of the steam traps. How to maintain the steam trap. So, the steam trap, it is, steam trap, it is a steam trap. So, 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 it is a Again, here comes the dirt, which is the main cause, because the dirt, it comes along with the working fluid. It gets logged into the valve seat. Once the valve raises, no, if suppose the dirt comes and gets seated in the valve seat, the valve doesn't shut off tightly. So what happens, instead of the condensate going out, it will be the steam escaping out. So it will be the loss for our system. Instead of gaining the efficiency, we lose the useful work done outside. So you need to have the steam traps properly maintained. So how to do it? By proper cleaning, removing the obstruction, thereby preventing the steam loss. Then another one is, inside the pipe, scale formation will be there. Of course, because it is at a higher temperature, moisture is there. So the scale formation will be there. So this can be reduced by use of a strainer. And that strainer too, it should be subjected to periodic cleaning. Otherwise, again, clogging of the materials will be there, pressure drop will arise, and accumulation of the dirts and the pipe foreign materials will change the pressure drive, and you will not have the steam trap working there. Because steam trap is worked on only due to pressure difference or density difference or temperature difference. There is no other any mechanical arrangement or moving arrangement there. It is all simple lever concept or float concept or a moving disc based upon the parameter of the working fluid. So wherever there is a change of, you have a combination of steam and condensate mixing there, you have a difference which makes the condensate to escape. So a very sensitive kind of maintenance is needed in case of steam traps. So the last one is the 3.6. Performance assessment methods for steam traps. How to assess the performance? So normally it is done by 3 testings. One is the visual way of testing. Another one is the sound testing. The third one is the temperature testing. So visual testing, we need to go around the steam trap area, observe the discharge place, and physically see any variation flow is there. Visualize each and every pipe, and it is only useful for light loads, because if it is a higher load, we cannot go inside and visually test it. So it is only for steam process industry, very lower loads only. We going for visual testing. And the other one is the sound testing. So sound testing, we have ultrasonic leak detectors. So stethoscopes are there, so which will detect any abnormal variations in the flow happens there. It will detect, and we can locate the place, and we can replace the particular area. So that is by sound testing. Here also it is not suited for heavy loads. And the third one is the temperature testing. So here we have infrared guns, surface pyrometers. By the changes in the temperature variations, the fluctuations in the temperature is measured, and by then we detect what is wrong. And ultimately we go in for the replacement. So these are the three main parametric ways of finding out the performance for the steam traps. So today's class, we had seen chapter 3, 3.5 to 3.7. So the slide will be shared to you. So here the problem, what we have worked, it is seen in the question papers. And the theory also will be from the first 1 mark choices we have seen there. So the last portion of the chapter 3 will be the 3.7. So there also problems have been asked. So it is efficient steam utilization and energy saving opportunities. That is the last topic of the third chapter. So that we'll see in the other class, next class, and we'll work out some problems on the energy saving opportunities. With that, the entire chapter 3 will get over. So there were some interruptions in between, sir, due to net. Sorry for this. And any queries, I can get it. Otherwise, I'll hand over to Dr. Bala, sir, please.
Thank you, ma'am. It was an excellent session. Today, it's not your fault, right? It is about the internet. All people talking about digital India. So digital is not accessed by everyone. So we need to understand it. So the people who are staying nearby power plants, they could not access internet. So we will be coming up with TANFINET. TANFINET would provide all such facilities. We believe so. Thank you.
Yes, sir. Thank you so much.
Thank you, ma'am. So, like tomorrow, you are about to take up the classes in continuation with it, or sir is yes, sir. சொல்லுங்க சார், யாரோ பேச வந்தாங்க. அசோக் குமார் சார், சொல்லுங்க சார். ஒன்றும் இல்லைங்களா சார்? சரிங்க சார், சரிங்க சார். இல்ல இப்போ நாளைக்கு நீங்க எடுக்கிறீங்களா மேடம், இல்ல கண்டினியூட்டி, இல்ல இன்னொரு நாள் டைம் எடுத்துக்கிறீங்களா?
இன்னொரு நாள் டைம் எடுத்துக்கிறேங்க சார்.
சரிங்கம்மா. அப்போ சார் வந்து நேத்திக்கு கிளாஸ் பயங்கரமா இருந்துச்சு, நீங்க அதை மிஸ் அவுட் பண்ணிருப்பீங்க. ஸோ சார் ஸ்லைடையும் ஷேர் பண்றேன் நாங்க. ஸோ சப்ஜெக்ட் நேத்திக்கு கண்டினியூட்டியே சார் நாளைக்கு கண்டினியூ பண்ண வாய்ப்பு இருக்குங்களா சார்? சத்யசீலன் சார்.
ஓகே சார், நாளைக்கு கூட நான் இது பண்ணிக்கிறேன். எனக்கு ஒரு டைம் ஸ்லாட் கொடுத்தீங்கன்னா அந்த டைத்துல
இல்லைங்க சார், 9 o'clock ஸ்டார்ட் பண்ணிடலாம் சார். இப்போ உங்களோட டைமிங் வரும்போது 9 o'clock எல்லாரும் இது 9 o'clock அசம்பிள் ஆயிருவோம் சார். ஏன்னா ப்ரையரா இருந்துச்சுன்னா வில் ஃபிக்ஸ் இட் அப் பை 9 o'clock itself. Nothing to worry about. நம்ம வந்து ஒரு ஸ்டாஃப் ரெடி பண்ணணும் அப்படின்னும் போதுதான் கொஞ்சம் டைம் எடுக்குது. அவங்க வந்து சேர்றதுக்கு பார்க்க வேண்டியது இருந்துச்சு. Now you are there, nothing to worry about, sir. We will have it by 9 o'clock. Today the participants are in good numbers. It is appreciable that we are pulling more number of people. So அது ரொம்ப சந்தோஷத்தை கொடுக்கும். ஸோ இன்னும் நிறைய பேர் கடைசி நிமிஷத்துக்கு வந்துகிட்டே இருப்பாங்க. ஸோ நிறைய டவுட்ஸும் வரலாம்னு நினைக்கிறேன், மேபி. ஸோ அதுக்கு
ஸோ டுமாரோ 9 o'clock நைட்டு நான் வந்து இது பண்ணிக்கிறேன் சார், கண்டினியூ பண்ணிக்கிறேன்.
ஓகேங்க சார், ஃபைன் சார். பிறந்தவன் சார் வந்துட்டீங்க போல இருக்கு, ஏதாவது சொல்றீங்களா சார்?
இல்ல வெரி சாரி, நான் லேட்டா.
ஓகேங்க சார், நீங்க இப்போதைக்கு வந்து பக்தி மார்க்கத்துல முழுமையா இறங்கிட்டதுனால நீங்க இன்னும் நிறைய சக்தி கிடைச்சிருக்கும். நாளைக்கு திரும்ப பார்ப்போம் சார், நிச்சயமா. ஓகேங்க சார், தேங்க்யூ. ஸோ நாளைக்கு 9 o'clock ஷார்ப்பா சந்திச்சுப்போம். ஓகே தான், தேங்க்யூ சார்.
மேடம் நாளைக்கு.
தேங்க்ஸ்.
இன்னைக்கு புதுசா செங்குட்டுவன் சென்முகவேல் புதுசா ஜாயின் பண்ணிருக்காங்க சாரு. கேஆர் சார் புதுசா ஜாயின் பண்ணிருக்காங்க.
சார் கேஆர் குமரேசன் ராமலிங்கம்.
ஓ புதுசா நீங்க பேரை மாத்திட்டாங்க.
இல்ல அது ஆரம்பத்துல இருந்து அப்படியேதான் வச்சிருக்கிறேன். அது அப்படியேதான் கொடுக்கறது. நம்ம இப்பதானே ஜூம் மீட்டிங்ல ஆரம்பிச்சிருக்கோம்.
ஓகே 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 சூப்பர் சூப்பர் பாத்துடலாம். வெரி குட்.
ஓகே சார் தேங்க்யூ சார் தேங்க்யூ.
ஸோ அப்போ நாளைக்கே நீங்க நிறைய பேர் கூப்பிட்டுட்டா சரியா இருக்கும். மேட்டூர் டிடிபிஎஸ் எல்லாருமே ஜாயின் பண்ணிட்டா கரெக்டா இருக்கும். நிறைய பேரோட சந்திப்போம் நாளை மாலை. மகிழ்ச்சி.
ஓகே சார் தேங்க்யூ.
நன்றி.